Hello class, this is Jasmine Usman Ganang. Together with my partner, Tuar Ismael, we will discuss to you about the COSETS in abstract algebra. I am the first reporter and I am assigned to discuss each definition, and Ms. Ismael is assigned to discuss each examples or application. So without further ado, let's begin with the definition of the COSETS. So what is COSETS? In mathematics, specifically in group theory, a subgroup H of a group G may be used to decompose the underlying set of G into disjoint equal-sized subset called COSETS. COSETS can be determined in a group and a subgroup of an element with the use of multiplicative or additive of the group and subgroup. In COSETS, there are left COSETS and right COSETS. COSETS for both left and right have the same number of element cardinality as does H. Furthermore, H itself is both a left COSETS and a right COSETS. The number of left COSETS of H in G is equal to the number of right COSETS of H in G. This common value is called the index of H in Z, and it is usually denoted by GH. The index of H in G is equal to the number of left COSETS of H in G. Note that even though G might be infinite, the index might still be finite. So now, let's proceed to the definition of the COSETS. Let G be a group with A, the element of G, and let H be a subgroup of G. The subset AH is equal or consists of AH, the absolute value of H, element of H, of G. It is also known as the left COSETS of H in G. And the subset HA is equal or consists of HA, the absolute value of H, element of H of G. And it is known as the right COSETS of H in G. Right and left COSETS. We define a set HA, which means the element of HA such that H belongs to H. This was the right COSETS. And AH such that A is getting multiplied with H from left. In the right COSETS, HA means elements A is getting multiplied with H from right, and AH means an element A is getting multiplied with H from left side. Then if we suppose to have H is equal to H1, H2, and so on, then HA is equal to H1A, H2A, and so on. And AH is equal to AH1, AH2, and so on. Then HA is the right COSETS of H in G, and the value of AH is the left COSETS of H in G. We can also have this in terms of additive formula indicating the left and right COSETS. The right COSETS H plus A is equal to H1 plus A, H2 plus A, and so on. And the left COSETS A plus H is equal to A plus H1, A plus H2, and so on. This value is the additive formula indicating the left and right COSETS. In this case, we use the multiplicative formula indicating the right and left COSETS.
In other definition, COSETS are subsets of the group that simply partition the group, dividing into even sections. So, let's say for example, G sub 10. So, in G sub 10, it consists all the elements from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And one of the subgroup is the the subgroup generated by 5. It is consists of elements 0 and 5. And by using the left coset strategy, a plus x is equal to the elements of a plus 8 sub 1, then a plus 8 sub 2, then so on. Now, if we add 1 on this subgroup, we will get 1 plus the subgroup generated by 5 is equal to the elements of 1 and 6. So, how we get this? So, we simply put 1, then 1 plus 5 is equal to 6. Then 6 plus 5 is 11. Mood then is 1. So, we will stop there because we just repeat the first element. So, let's move on by adding 2, 3, and 4 respectively. In adding 2, we will get the elements 2 and 7 using the same process. In added 3 to the subgroup generated by 5, we will get 3 and 8. And by adding 4 to this subgroup, we will get the elements 4 and 9. Therefore, the subgroup generated by 5 added 0 to 4 respectively are all cosets of G sub 10 since they partition G sub 10. So this is the subgroup, and this 3 is the cosets of sub 10, G sub 10. Take note that the number of all left cosets is always equal to the number of right cosets. However, left cosets do not always equal to right cosets. We must keep it in mind. Next problem, find all the cosets of subgroup 4J of J. 4J is multiple of the integers. The integers there is the J. These integers is multiplied by 4. So, the G integers consists of all negative and positive numbers including 0. So, if we add 0, we will get these elements. 4 multiplied by the elements of integers, J. So, 4 times negative 2 is equal to negative 8 plus 0 is negative 8. 4 times negative 1 is negative 4 plus 0 is negative 4, and so on. Then if we add 1, 4 times negative 2 is equal to negative 8. Plus 1 is negative 7. Next, 4 times negative 1 is equal to negative 3. Plus 1 is negative 3. And so on. For adding 2, 4 times negative 2 is equal to negative 8. Plus 2 is equal to negative 6. Next, 4 times negative 1 is equal to negative 4. Plus 2 is negative 2. And so on. And then, 4, we will add 3 to 4J. So, 4J plus 3. 4J is equal to negative 2. So, 4 times negative 2 is equal to 8. Plus 3 is negative 5. And so on. By repeating the process to all elements of J, we will come up to these equations. 4J plus 0 is consists of negative 8, negative 4, 0, 4, 8, and so on. For equation 4g plus 1, it is consists of negative 7, negative 3, 1, 5, 9, and so on. For 4g plus 2, it is consists of elements negative 6, negative 2, 2, 6, 10, and so on. And for the equation 4g plus 3, it is consists of elements negative 5, negative 1, 3, 7, 11, and so on. We have partitions the integers to found all the COSETS. And let's conclude our discussion about the definition of COSETS in its application.